Hi, AP. In particular, my teal class, I woke up in the middle of the night last night and was like, oh my God, I never went back to the slide and explained what a pi bond was with the picture. So my apologies. Let me do that now. Just to review, sigma bonds is the head-to-head overlap. Okay, so the overlap has to occur with or on the inner nuclear axis. Okay, when you have, like, let's say you have p orbitals perpendicular to these p orbitals here, something that looks like this. All right, so here we have one nucleus, here we have another nucleus. Okay, so this would be known as the inner nuclear axis. You can see that the p orbitals are not on there. So instead, what happens is there's a little bit of overlap both above and below the plane. It's not as strong as some head-to-head overlap could be, but there is still some overlap. This is only one pi bond that is shown, okay, with that sideways overlap, even though it occurs both above the plane and below the plane. That still is only one pi bond. Okay, so in order to have a pi bond, you're going to have first a sigma bond. So that's one thing. And then I think both pink and teal is going to benefit from this. So what you do to actually figure out what the hybridization is, we're really only going to talk about hybridization around the central atom. You have your molecule, and then you draw your Lewis structure. Okay, so this is methane. I drew my Lewis structure. It checks out. Then you analyze it for electronic geometries. So the electronic geometry here is tetrahedral. Okay, and because you've basically memorized it, tetrahedral implies sp3 hybridization on the carbon, right? So the carbon is sp3 hybridized. Now that's the question that would be asked. If it asks about the hydrogen atomic orbitals, those are just s orbitals. They're not participating in hybridization. You're really only going to be focusing on central atoms, okay? Just like when you do geometries. Okay, let's go over to the BCl3. Remember, B is allowed to not have an octet. It's one of the exceptions. Okay, so we analyze this. There are three atoms to which boron is bonded. There are no lone pairs on the boron, so that's a trigonal planar situation. And if you look at, or if you already have it memorized, your hybridization, that would mean the hybridization with respect to boron is sp2 hybridization, because you only have three things around a central atom. They can organize themselves 100-degree bond or 120-degree bond angles. You might say, well, that looks like 90. Yeah, because that's a Lewis structure. If I were to do a quick sketch that's not a Lewis structure, it would look more like this. Okay, it is planar, and then these are 120-degree bond angles. Okay, I just wanted to go over that because I did not think I did a very good job of it yesterday. Have a great weekend.